Hello, and welcome everyone to a new edition of the Uplink. My name is Travis Teague, and many of you know me as Teague over on our Helium Discord. I serve as Developer Growth Lead here at Helium Systems, working with building out our developer community, and I also run our weekly Helium Hacks Happy Hour. So thank you to everyone for giving us your time today. We have a lot to go over, so in order to fit everything in, we're going to have a bit different format than we've done on past Uplinks. So I hope that everyone at this point knows that Helium is the world's largest public LoRaWAN network, and we're expanding this out at an incredible rate. And many of you who have helped build out this network may not really know as much about how to actually make use of the Internet of Things aspect of why we built this network. And that's what we're going to dig into today. So for a more detailed background on Helium or the infrastructure side of the network, please check out some of the other great uplinks or hit up the documentation site we host over at docs.helium.com. And there's tons of great material over there on everything from earning HNT using the blockchain to embedded systems development. So, Paul from over at dis91.com is joining us today, and we're going to chat about some use cases on the network. And these are projects that anyone can jump in on and implement whether you have Helium hotspots or not, right? So using the Helium Developer Kit or other inexpensive microcontrollers, you can build out an idea that makes use of the expansive coverage that the entire Helium community has built out. So without further ado, Paul, thank you very much for joining me on the Uplink. And, I know you've been involved with Helium for a while now and have written quite extensively about it. And pleased to have you on the show. You did Hacks Happy Hour a while back and talked about some of the projects that you have going on. And happy to have you here again. And just, I'd like to pick your brain a little more. 2 hours wasn't enough last time. So welcome.
Yeah, thank you for inviting me, Travis. It's always a pleasure to be with you and to talk with you. So that's really cool. I'm happy to be there.
So what have you been up to?
I'm working on many different things, and currently, right now, I'm working on another technology that Helium. So I won't talk a lot about it, but it's quite interesting. It's a satellite IoT with a Pinault. Which is a French company who already have 8 satellites turning around Earth. So that's quite interesting in terms of technology, and it's complementary technology. So something I investigate these days. And on Helium, my project are the field tracker, so the field tester. So I'm working on that too. I have some code to finish for it, like being able to put the credential through the USB cable, the serial cable. So the idea is that you just have to upload the binary of the firmware instead of having to compile it and so on. So it's gonna making more easy to use it. So I have some work on this to finish.
And we talked about this, I guess, over on Hacks, but just in case anyone missed that, can you give just a brief rundown of what this device does or why someone would, want to use something like this?
Oh yeah, sure. In fact, it responds to many different things we had to manage when we are deploying the network. I mean, before deploying the network, you want to know in your city what are the best place to deploy your hotspot, which is basically a place where you are extending the network, so you are not in the middle of many other hotspots where there is a high density, but you want to be able to witness with a maximum number of hotspots. So with that tool, this tool is basically just emitting a message over the network, but there is a response from the network with information like the CNIDE range, the number of hotspots that have received the signal, and the min and max RSSI received by the network. So basically, you can work on a street or on a mountain or road or thing like this, and you can show what is the coverage on that position, the number of hotspots that are listening to you, and so on. And so you can decide what is the best place to do. So that's one thing. The other thing, which is really important, is once you have deployed hotspot, you want to know the coverage. and you want to enrich the mapping, it's really important to have a mapping of hotspots, coverage mapping, because I mean, if we want, I mean, in my point of view, I'm not doing Helium to mine HNT. It's quite good to mine HNT, but what I want to do is to create a network, a viable network. Because I mean, if I think about HNT, the value of the HNT in the future will be relative to the usage of the network. So we need to build a network to convince people to use the network. And what is really important for convincing people to use the network is to show them that the network is working everywhere. If it's just a hotspot, I mean, people in the telecom area will say, okay, Helium is just Mrs. A network. It will never work. There is many hotspots, but the coverage is null, and so on. And so if we want to fight against that and prove that the network is strong and it's working well, we have to prove that the coverage is there. We have to prove that there is redundancy on every point of the coverage map. And so we need to measure that. And that tool, basically, every time it sends a message, it push the information. There is a GPS inside, and it pushes the information to the mappers. And so it enrich the mappers. So that's quite interesting in terms of information for long-term perspective for the network. And that's fully open source. The idea was to do, because I mean, it's not the first device like this. The difference is this one is really integrated with Helium, with the mapper, with Cargo, and so on. So you can benefit all this ecosystem, but also it's fully open source. So you can build on your own. It's a YO terminal you can buy on Steed. And inside this, there is a specific PCB I've built, which is open source on GitHub. So you can order your own, build it yourself and use it.
Yeah, and I actually picked up recently. I had built kind of a Frankenstein board based around your firmware and your design that you had done. But I recently, just 2 days ago, I guess, got a kit that I ordered based off of your open PCB design and also the 3D enclosure design. And so this is a unit that I printed up, and this has the GPS, a battery housed inside, and the antenna. It's very easy to assemble. Like you say, this is open source, and so the firmware, if I want to, to dig through it, if I want to make modifications, and this works in US and EU regions, but it allows me to kind of make whatever modifications I want, and I'm assuming you'll hear out a pull request if someone has modifications they have on it. But you mentioned a deep integration into Helium. Could you kind of go a little bit more into what you mean by that?
Yeah, I mean that. I mean, most of the field testers you have on the market, they are standalone device. So basically, they just send a message and they just ask for acknowledgement, and they get the reception, the signal of the acknowledgement, and they show this information basically. And they can also send the GPS information, but I mean, there is a raw message, and you have to create an integration to transform this GPS information into a message that a mapper can integrate, which is, I mean, it's quite good. But if you're not a technical guy, you will have to deal with JavaScript, with HTTP integration, with creating a code, and so on. So it can be a bit complex. And so I would like to simplify this, because I mean, in the Helium technology, the Helium network, we have really techie guys, but we also have something like 75% of people that are starting in IoT technology, not developing an Arduino, not making all that stuff. And so I want those people to be able to participate, because as I said, it's quite important to map. So everyone need to do the effort of mapping. And so I work on the Helium integration to make sure that anyone will be easily connect this device to the network and make the integration. So I mean, When the device is sending a data to the Helium network, there is a simple integration I've made. So it's really easy and anyone can do that, that contact my own servers. And so my server process the information, send the downlink for the network information back to the device, and also send automatically the information to the mapper. So this is, I mean, you have nothing to set up or to do for this. So that's quite easy to integrate. That's the objective. And after, I mean, if you are the tech guys, as you say, Travis, you have all the source code, so you can improve the source code. You can send me some pull requests. I know that there are some bugs, like when you have the last 32 data start displaying on the screen. And I know that I have a bug currently. After the 32, on the first column, you have the 33rd data, which is displayed instead of the new one coming. So the first bar is wrong after 32 messages. So that's bug. I will fix that, but if anyone can fix that before me, that's quite cool.
Awesome. And so you know, being on GitHub, you've got an issue list, and so you know about these things, and you know, I guess they are being tracked. Let me get some data going through this, and I'd like to kind of show everyone what this looks like, because you can just thumb between the different charts, and I've only had this running for a moment here. I should have joined this a little bit earlier, but it's very easy. You have a 5-way, you know, little clickable 5-way navigation button, and then like 3 buttons on the top that allow you to go between your modes. You can set, I guess you could do pretty much everything you'd expect a LoRaWAN field test device to do on this thing. I mean, you can, you know, change your spreading factors. You know, set what type of antenna you're using. Let's see here, and then you will have a running. You can see just a little bit his graph so far, but you know, you have a running graph across your screen, and then your tabs and your heads up at the top.
Yeah, and if you move the stick, the 5 direction button, you can change what you want to display. So you have the downlink RSSI, the downlink SNR, the number of retry, the network or RSSI, and so on.
So this screen that says hotspots on it.
Yeah.
Tell us about that.
Yeah. So that's a really key feature. Currently, we still have a bug in the router, so we only have one. But yeah, it's gonna be fixed soon, I hope. And so the idea is, when I send a message, I mean, it's like the discovery mode, basically. If you know the discovery mode in the hotspot. So you are sending a message to all in the air, basically, and all the hotspots that are receiving this message will send it back to the router. And if you activate the option in the router on your label to say, I want to buy all the messages coming to the router, so you will pay 1 DC per hotspot, but I mean, it's not really expensive, so you can do that. And,
right.
And so a message will be built with the list of hotspots that has been received as a message. So this will be sent to my server, so my backend server, and my backend server is processing that to respond to the device with a downlink communication containing the number of hotspots and the minimum RSSI and the maximum RSSI. And so on the device, you have 2 screens, one which displays the number of hotspots receiving every messages, and another one with a bar graph with a min and max display. So you can see that, and that's, I mean, once the router will send all this information, it's going to be really, really interesting. I mean, it's also interesting when you are doing mapping. I mean, imagine that you want to deploy a fleet of temperature sensor in the city, or environmental sensor, like for pollution or things like this. You want to deploy that in your city. And you want to make sure that the coverage will be good, which means there is a strong signal, but also there is redundancy. Because, I mean, if a hotspot is at home of John Doe, and John Doe have a problem with internet connectivity or with a power supply or anything like this, his hotspot may be shutting down. And if you only have one of redundancy, your sensor will discontinue to communicate. So with such tool, I mean, you can check before placing a device that the coverage is good at this place. I mean, strong signal and 2 or 3 or 4 or 5 hotspots receiving the information. So you're quite sure that, I mean, if there is a problem with one hotspot, 4 other will capture the information. If 2 hotspots, 3 other capturing the information. So that's quite cool.
Sure. Absolutely. And that brings up a good point here, which I think a lot of people may not necessarily understand, that in order to develop a sensor, or, if I have a use case for LoRaWAN, for the Helium network, I don't necessarily have to be rolling out my own hotspots. Because there's so much coverage that is already out there on the Helium network. I don't have, it doesn't have to be my gateway, my hotspot for me to use the network. I can, build up a device like this and just go somewhere and just see if I have coverage, right?
Yeah, exactly. That's the purpose of this kind of tool. And
Yeah.
it's quite important. I mean, when you are a service provider, and this is the advantages of using Helium. I mean, currently, service provider in LoRaWAN, most of them are deploying network. So they have a solution for smart home or smart building or smart city. So they are proposing a solution with a network. So they are deploying many gateways around devices and application, basically. So that's, I mean, interesting, as they can sell all these different bricks all together to the consumer. But imagine that you can come and say, I will make a private network, a private network server. I mean, so to the consumer, the data will be safe, basically. I mean, they will be encrypted from end to end, so no one will be able to see the data. And with that private network, I will get benefit of the public Helium network. So maybe for a city, for my customer, I will just have to add one hotspot somewhere because there is a white zone, but all the other places are covered by the public network. And basically, as a solution provider, my price will be lower because I won't have to pay for deploying the other hotspot, and I won't have to maintain the hotspot, because, I mean, it's quite expensive. If you are looking for a radio tower or a rooftop to deploy your gateway, I mean, it's some $1,000s per year. And if you need to have someone coming to update the gateway or check it's working well or change it every 2 years or something like this, it has a cost. So if you can avoid all these costs, I mean, you are in a better shape to sell your service to your customer. So that's quite interesting.
And you've written a very extensive article on this about leveraging, or the Helium network to put a private network, to stand up a private network on top of it. And your website, sorry, we should cover this, disk91.com. Please go over there and check out some of the great articles over there. But no, that's a good one, and it goes quite in detail about setting this up and how you're running this on top of Helium.
Sure. Yeah, I did that blog post because, I mean, I made my own router. So, I mean, as usual, I mean, when I'm doing something, I'm taking notes and I'm sharing my notes. So, and I mean, as this is something I run in production, the blog post is updated every time I touch it. So, I mean, today I made an upgrade of my router and console. And so I had some trouble, and so I described how I fix that. So it's, I mean, if you want to build your own router, there is a really good documentation also on Helium. But if you want the detail of my experience with all the command F tip and explanation of why, you can find it on my blog post. And there is also all the economy around the router, which is I hope quite described. Well described, as the price, I mean, the price of communication, we always say one message is one DC, but it's really a simplified approach of the blockchain mechanism. So I've made also another blog post to really explain all the different transaction and the related cost for this transaction. So if you are a service provider, you have all the tools basically to create your business model using Helium. And I mean, if you want to compare with other public services, or if you want to compare with a private deployment, basically you have all the economical stuff.
You have, I know recently you've written some other articles, and I'd kind of like to go back to talk about use cases or in node type, IoT use cases.
Yeah.
Like for example, if someone wanted to, I mean, I know here in Houston, there are some community gardens, and, I'm kind of getting back to the point where, because especially in urban areas, there is such, pervasive coverage on the Helium network, you really don't have to concern yourself so much, most likely. I mean, you need to, test it out, but you may not even have to worry about hotspots or gateways. You can get just small, in node or sensor devices and put them out there and route through to your own private, applications on the back end. And you had a project recently that you were doing, like an agricultural project.
Yeah, I mean, kind of agriculture. It's my son, my son vegetable garden. So it's small agriculture, but I mean, it's applicable everywhere. The idea is to get the information on how do we need to put some water on this garden. And as you say, for community garden, it's quite important, because I mean, when you want to get the vegetable or the fruit, you always find someone. When you want to start the things, you always get someone. But when you want to put the water on every 2 days or thing like this, sometimes you are missing people. Just because everyone is thinking another one has done this task. So here the idea is just to measure the humidity, the moisture of the soil, and so when it's under 50% or 40%, you know that you have to do something. So the device is basically, it's really, I mean, simple device. I use a rack WISblock solution for that, because I had a rack WISblock, so I did it with this. It was quite cool, because I don't have the device. It's in the garden. Maybe I will get it.
Where it should be. Yeah, absolutely.
But I will share the dashboard if you want.
Yeah, there we go.
Great. Yeah, so the device is on a photo you have here. I don't know. Yeah, there is a bigger picture here. So what was really cool with the WISblock kit is that there is this waterproof enclosure, which is made for the WISblock with a solar panel. And so for the garden application, it was really cool to have the solar panel. I don't worry about changing the battery or anything. I mean, it's the last time I measured the battery, it was a 4.1 volt, which is the maximum. So it's really charging. So it's cool. So I have this waterproof enclosure. Inside there is a WISblock. I think we have a picture here of the WISblock with an extension board. The extension board is just there to have an ADC, so analog to digital converter, and basically to measure the soil moisture. I just connected the ADC to 2 big screws. You can see that there. So it's, I mean, really homemade low-cost stuff basically for this. And you see there is some duct tape on the screw to have no conductivity at the beginning. So I measure the moisture at 3 to 4 centimeter. So I have the underground moisture, and I mean, it has been the main difference with something professional is, I mean, there is no calibration. My calibration is just if I put it on a glass of water, it's 100%. And if I put it in the air, it's 0%. This is how I did the calibration, and I'm considering it's quite linear. So basically, my percentage is wrong, but I mean, I don't care. What I just need to know is what is the level and what is the decrease or the increase, and that's it. When it's raining, basically, I have 98%. And after 2 or 3 days of dry, it's something like 50%. So I know that under 60%, I raise an alarm. I receive an email. The system tells me it's time to put some water on it. So it's the source code is also available. I mean, if someone wants to make its own, all the pieces can be ordered on rack. Shop and not the big screw. You have to find another shop, but for the rest, it's you can get there. And the source code is on my GitHub. There is a link somewhere in the in this blog post. And for the dashboard, because I mean, when you do an IoT project, you spend 1 hour to do something simple on the hardware part. If you have the good module and the good environment, it's really fast. I mean, I spend less than an hour to make that. But once the data are sent to the network, you need to get this data and to make them processed by a system, an IoT platform, to be able to display something for the users. And you want to have it really simple. So there is many different platforms that are available. Historically, I'm using MyDevices Cayenne. Because they are existing since a while, and they made a platform. I mean, I think they have never finished the platform. It's like some things they develop pretty fast at the beginning, and then they have stopped lots of development, by the way. But it works correctly, and it's free, so that's quite cool. I mean, it's free for the use I have. So it's quite cool. And with the Helium, you have an integration on the Helium console. So it's really easy to use MyDevices Cayenne. Basically, I mean, you have here a screenshot. It's the Helium console you see there. And on the Helium console, you just select the integration type Cayenne. You give it a name. You attach it to a label corresponding to your device group, and that's it. You have nothing else to do. So it's really cool for that. And on Cayenne, you have to make the link. So on Cayenne, you select a device type Helium. So integration is quite easy also. You select Cayenne LPP, which is for the format of the payload. I will explain a bit later. And you select your dev UI, and that's it. And the link is made. So you have nothing to program, nothing to do. And so what is quite cool with Cayenne is, I mean, in fact, it's a bit expensive in terms of data. I mean, in terms of energy, because in terms of data, don't be afraid, we are just talking about 12 or 16 bytes. Okay, it's 4 times an hour. So okay,
we can get a little picky when it comes to packing bits into payloads, but
yeah, and here it's not really optimized. Basically, in Cayenne, you are putting 1 byte saying it's the sensor number 1, for example, temperature. Then you have 1 byte to say this is a temperature. And if it's a temperature, you need to send 2 other bytes with a temperature, a int, a signed int temperature information. I mean, it's something like 70 degrees Celsius or something like this. So the format is predefined, but when your device is sending this information in this format, Cayenne automatically built the dashboard. So you have nothing to do to decode the information and so on. So it's really easy. So you get a dashboard like this one. I will show you the real one. This is one. You can make it public. So you can check my garden.
So this is live. This is your garden right now.
Yeah,
okay.
This is live. So see that my son put some water on it tonight. So maybe we're gonna see that. And so I decide to have what you change on the dashboard is, I mean, I decide to display the soil moisture as a, I mean, as a, I don't know, I mean, like you see it, but I can, if I prefer a graph, I can design my dashboard using a graph like this one. And also here you see the current graph. So currently my son put water on it. I think it has not been updated yet, as it's every 15 or 30 minutes. So I think it's 30 minutes. So maybe it's not yet updated. So it's still low, but next point will be higher. And so you see all of this. So here we did not put a lot of water, and then we put some water and sun. So that's fun. And I also have the pressure. So you see the atmospheric pressure, the air temperature. So it's quite warm today. You see that we are 33. It's interesting. It's the temperature really near the soil. So the temperature in the air, in fact, is a bit lower right now. But as the ground is getting sun during all the day, there is some I mean, it stay warm longer. In the morning, it stay more, and we have the air humidity also. So all this information are displayed, and we can check them anywhere in the world. You know that. I mean, here, what is funny is my garden is a bit 30 meters from me right now. It sent a message. The message is captured by the hotspot, which is on my rooftop. Then it goes in North America in Helium console. Then it goes back to Cayenne. I don't know where they are, but maybe somewhere in Europe. So they go somewhere in Europe, and then I can from my laptop check this information. So we are turning our own world one or two times to get this information, but it's something immediate. So that's quite cool.
Oh, that's very cool. That's very cool. And all of this, I guess the data comes through, like you said, from the console, and then you break out to the Cayenne integration. What we have on the Helium console are a number of, I guess, native integrations. And so you don't have to just have one of them. For example, you can have a Cayenne, and we're adding, quite a few of these. Every time we release, we're trying to add new integrations. And recently we added a Google Sheets integration. And so if I wanted to both store all this data in Google Sheets and send out to the Cayenne dashboard, I would just attach two labels to the, to this and feed that data out in both directions, and have that recorded on the Sheets end as well as displayed over in Cayenne. So.
And that's quite important. I mean, when you want to deploy an IoT solution, it can be. I mean, if you're on your day-to-day job, you have many use cases that could be interesting. Let's take home. Work desk. On a work desk, we have application like when you have a limited space. I mean, you have a 100 places for people and you have 200 employees, for example. I mean, it's something more and more usual. When you arrive, you have no assigned desk. So you want to find a desk. You want to be sure that there is a desk free and you want to find it. So there is solution you have on your desk, just like a motion sensor. And so if someone is at a desk, you have an activity thanks to the motion sensor, and so you can detect that. And so this small device reports the information, and you can have a map with all the desks, and you can see what are the free desks, what are the used desks, and you can find a place. So that's one example. The other one is when you have a meeting room, you want to know what are the meeting rooms that are really free or occupied, because when you take a look at the planning in big company, I mean, they're always used. And when you work in the building, you see a lot of meeting rooms that are empty. So the IoT can give you the right information immediately on where are the rooms that are empty or used. You can also work on air quality. You can also, you are some stuff that are shared, like video projector or network equipment or things like this. You want to get a location of them inside the building. So you can use IoT for this. I mean, there is many things. And while I'm talking about this is, I mean, in your company, if you want to create some transformation on the, I mean, on the usage, on the employee experience and so on, and you want to push something, you can quickly design a device. They are really simply devices. I mean, presence with a motion sensor, it's something you can develop in 2 hours if you are a little bit familiar with Arduino. So it's something really fast to do. The meeting room occupation is the same thing. So it's really fast to do a proof of concept in the hardware part. But if you want an adoption of this, you really need to have a cool dashboard. Because I mean, people, when you will take a discussion with your boss or anyone in the company and say, I have this good idea, I done it alone in my desk or with 5 or in my floor or something like that. You want to expand this. They will not show your device. No one is interested by your electronic device, basically, or just 5 minutes, but after they are not interesting. But what they are interesting about is data, because an IoT data, an IoT device, just a data sensor. I mean, it's just something getting data from the real world and pushing it to an application.
Yep.
And so they want to see dashboard, and so you need to have a cool dashboard. And so you have to get a quick and easy access integration system. I mean, if you have an IoT platform which is really efficient to make dashboard, it's quite cool. And I mean, as you say, Travis, in your company after, they will say, for example, okay, that's cool, your system, but in your company, we are working with Azure, so how can we do that? Yeah, I mean, it's the IoT platform, it's the backend, Helium backend is able to do a quick integration with a different platform. You will be able to show that it's really easy to switch from, I don't know, Cayenne to Azure IoT Hub or whatever, and get something cool to present, to show.
You start really identifying patterns when you're doing IoT devices, because IoT devices aren't necessarily very complex. They probably the most complex part are dealing with like deep sleep states and power consumption management.
And not, I mean, if you have really simple, I have a board I really like for that. Just I really like this board. I don't know if you know this board. It's a LoRa radio node. So you can buy this board for about $10 or $15 on AliExpress. And this board is just, I mean, you have a RFM 95, which is a really common LoRa solution.
Which is what you actually used in this guy, right?
Yeah, exactly. Yeah, it's really low cost and really good. And there is an Arduino, an Atmega 328P. So I mean, there is a basic Arduino system, and you also have a battery holder. It's the only thing that is a bit disappointing me. I mean, there is a battery holder, but the type of battery you can use with that is really limited because you need more than 3 volts. And you also need to have a peak, a power peak, which is quite high in LoRaWAN. So most of the lithium battery are not good. You have a LEFE4, which are fitting well, or after you can connect a LiPo like this, which is okay, also good. But I mean, with the battery, it's really compact and so on. So this, and you have a lot of different IOs there. The only thing you need to think about is you have to do by yourself this tiny soldering. It's for the interruption system. And basically here you have a really compact system where you can do whatever you need if it's quite small. Because I mean, the LoRaWAN stack is a bit big, but it fits here. And you still have something like 2 kilobytes and 100 of 200 bytes of RAM. So it's really limited. But if you want to measure temperature, if you want to measure presence, if you want to measure air quality or things like this, it's okay. You can do with such thing. So you get a board like this one, you just make some Arduino code. It can go low power with a really, really low power consumption. I mean, with a battery there, you can have about 1 or 2 years of autonomy with the system communicating every 15 or 30 minutes. So
yeah, and you know, whatever protocol you want to talk with. I mean, I've built some up that talk to like UART based gas sensors, just using a $2 ST Blue Pill clone board that you can get for literally under $2, and throw one of those RFM95s on it, and then you've got I guess probably a regular. Well, you probably replace the regulator, get your voltage down a little, and you can absolutely run those things with the little solar panel for
forever.
Yeah, exactly. Just go on and on. I'm going to take this opportunity though. You had mentioned the WISblocks earlier. And that's what Helium, or we've kind of built the developer kit around, is these rack wireless WISblocks. And in these kits, you've got a couple boards, 2 cores that are using, which are replaceable, these cores, but these use the Nordic, which has a BLE stack and a LoRa stack on it, which means effectively you can hook it up to your cell phone and program the thing over the air, over BLE. And then you've got all sorts of breakouts, if you're Modbus 0 to 5 volts, 420 milliamps, and different ways of interfacing. Like you said, on your project there, you were using what is the name of the breakout board? Was it this guy?
Yeah, this is it's an extension for Grove, the Grove extension.
And which is really, really convenient. I mean, because you can, there are hundreds and hundreds of different sensors that you can attach to those. And, I think most of them are pretty cheap. So
what I really like with the WISblock stuff is, if you, as I said, you are at work and you have a good idea to optimize the employee experience and so on. So you get that kit, you have the sensor, maybe you need some other sensor, you can buy them and as additional parts, and you make one. And it works. You have it creates an advantage for your employee or company and so on. And so you want to make 100. And with WISblock, it's really a legal stuff. So if you have to build 100 of WISblock devices, you can do that in a day.
Yeah.
It just switching, the different sensors with the motherboard and so on. So it's just screwing stuff. And so that's quite cool because you can scale. If you have to do 1 million, it's maybe not the right solution because it doesn't cost. Right. Okay. But if you have to do 100 or 500, it's really easy. Anyone could do that. You have no soldering, complex connectivity, just putting things together and screwing.
And that's something, when you say and screwing, that's because, all of these click together with these sockets, and then you throw a screw in, and so they don't vibrate loose. And so they're industrial rated. But one thing that Rack Wireless is really promoting here is the prototype to production. And so if I get, something built out after work, and I'm like, hey, I got the firmware kind of tuned in, this is how I like it. I can go to Rack and say, okay, like the solar case that you showed earlier, Paul, I could say, okay, I want 200 of these made. And then, I'm not necessarily the one that's screwing all these together and, putting the batteries in or whatnot. I believe that Rack will work with you on going to production with these. Cool. And so it is very cool there. But if you just, as far as, I wish I had this years ago, honestly. If you try to wire something up, and Paul, if it's okay, you do a prototype by hand and you wire everything and you get it. But when you start doing 50 of those by hand, without a modular system, man,
I've made something about 300 trackers by hand right now. So yeah, you really appreciate when you have something which can
Yeah,
really.
and that's why I really appreciate what they're doing here with these kits. It makes the development of it a lot easier, especially when you're doing like I say small scale. I mean, if you need to do 100, I think that's absolutely doable. But it's a neat kit. It has a lot of sensors. In the U.S., you can get them over at Parley Labs. Otherwise, just through Rack Wireless or AliExpress. I know carry it, but yeah. Was this the first time that you'd really done a full project on the WISblocks? Or?
Yeah. I mean, I've tested the WISblock a bit before, but it was just a test. And when my son started doing his garden, I say, yeah, I have I just found what I can do with the WISblock. So yeah, that's I mean the real first project I did with WISblock basically.
Yeah. And I mean, what would you say to someone like new to, I don't know, Arduino, C, plus plus development, and maybe even new to IDEs or programming as a whole? I mean, were you using Platformio or?
I really prefer Arduino platform, honestly,
Yeah.
like platform IO. I don't really like Arduino environment basically. But I mean, to begin, I think the Arduino environment is I mean it's really super easy. It's too easy when you are a developer with experience, but when you start, it's I mean it just good enough. I mean that it has been made for this. So you just tip your code. You have a lot of example. You just compile, and I mean when you deploy, it automatically saves the files and compile and deploy. So that's cool. I mean, so yeah, I really recommend to start with the Arduino environment and to start with the examples. There
Yeah.
are a lot of examples. I mean, you just put all stuff together. You use the example. You download it and you start getting something. You connect it to the network, so you have to set up the DevE, API, AppSkey, and so on. And once you're familiar with that, you start tuning your code by mixing 2 or 3 different examples together. You start optimizing the power consumption and so on. And maybe the advice I can have is, I mean, don't try to make something too complex at start. I mean, for example, power consumption, it's really important to have a deep sleep, but optimizing power during communication or during sensor gathering in data and so on, it's not what is important. I mean, you have 95% of the time a device is sleeping. If you just optimize this part, you're gonna have a battery life duration for months or years.
Or longer. Yeah.
It's good enough. Don't try to do something too much complex, or don't try to spend hours optimizing your code. It's I mean, to get things started, it's not really important.
And what you start learning is that you're going to be using the same kind of components and the same, kind of approaches over and over for end nodes, for sensors, for data acquisition sensors, right? And I mean, you're going to have those deep sleep modes. You're going to have your boot ups, or you're going to have your diagnostic, modes if you want to change modes with downlinks. And you start using the same patterns over and over, and it gets where it's really is very simple to knock out an end node implementation of a unique sensor in very short order. So
it's always the same thing basically. I mean, for that reason, I don't really, I really use Arduino when doing simple thing, open source. I mean, because it's really open and easy to use. Once you start developing devices on a regular basis, it's quite limited. And honest, personally, I don't really like all the library provided with Arduino World, because they are they are developed by you don't know who, not always maintained, quick and dirty, and so on. So for the device I'm selling, like my Fox Tracker or thing like this, I'm using my own SDK, which is also open source. So you can check my GitHub. It's a big IoT SDK. And as you say, I mean, as you do always the same thing, I've tried in the SDK to put all what we always do we on IoT, like you say, it's deep sleep. So I mean, deep sleep mode in Arduino are really limited. It's just when you are replacing a delay, instead of having a delay, you have a deep sleep delay. But when you do a device, you want to be wake up by a serial line, by a sensor, by an ERQ line, or thing like this, or on regular basis, basically, in case you have timers in background or thing like this. So all of this is managed, for example, in my SDK, but also when you, I mean, in LoRaWAN, you have to store your app key, app AV, dev AV, and they are sensitive information because they are responsible of encryption. So you need to use like a secure element. I'm not really someone who loves secure element because they are quite expensive. I mean, I want detail, but I'm not a big fan. And so I did a software secure element, which is free. It's not safe as a secure element, but I mean, if you don't have the source code and don't do hours of reverse engineering, you won't be able to access the different keys.
Yeah.
So this is packaged, and there is also all the debugging. There's something really important when you do a project just for a weekend. I mean, you put some serial.println and that's good. Okay, but if you have something in a field, you need some serial print, but you also need to store some event in Flash, for example, because if you know you have a problem with a device and you get it 15 days after, you won't have access to what has happened in the field. So
Yeah.
you need to have some trace of that. So there is some event log that is interesting to consider. So I have things like this, and you have all the setup phases. You need to be easily set up the device ID, and the frequency of communication, and many things like this. So all of this can be also simplified. So there's always the same thing you need to do, as you say, and so I've tried to gather all that stuff in IoT.
So just abstract it out in the SDK so you don't have to deal with a lot of the minutia of all of these little things. You just say, okay, I need to save this state, or I need to.
Yeah, exactly. You have all the configuration, you have state machine, you have many machines. And the other point why I did that, but it also worked partially, but correctly with Arduino, is portability. My experience in IoT, I mean, IoT is growing really fast. So I worked in, I mean, I have lots of device and Sigfox environment, and now I'm also doing LoRaWAN. But the ecosystem is changing quite fast. At the beginning, ST was not really part of LoRaWAN. Now they are leader in LoRaWAN. In Sigfox, it was telecom design at the beginning. After it was sorry, I miss the name of. Basically, now it's ST is coming and this part with different solutions and so on. And so what I mean is the first device I've developed, they are really obsolete. 2 or 3 years after, they are obsolete in terms of hardware. And so I've released them with new revision of hardware. And at the beginning, I was using a SDK provided by the microcontroller provider. And so later, when I have to review the hardware, it means the hardware to transform the hardware, it has been something like 1 day of work. But I also had to rewrite all the firmware. And this has been something like a month of work. So it's quite long. So the idea with my SDK or also with Arduino is you have a platform where you can have different hardware targets, and your code, your functional code can stay the same over the different hardware revision. And so that's quite important to have in mind.
Yeah. You mentioned ST or ST Micro earlier, and they've come a long way with their Cube, and not just Cube IDE, but the Cube, I guess, remapper or what?
Yeah, Kubernetes.
which allows you to move a lot easier than you could a couple years ago between different device families and or different microcontroller families within the ST ecosystem. And so if I wanted to port something over and move a UART over to these lines, or to move things around to make things, work the way I want, they have something that will go through and look at all my timing lines, in a system and say, hey, no, this is funny. It won't necessarily fix it for you, but it'll tell you something's funny over here. I really think that tool has grown up significantly in the past few years. I'm pretty impressed with it now.
Yeah. Well, and what I really like is that, I mean, I'm developing I'm on Macintosh and on Apple, and previously I was needed to have a Windows system, so Windows VM, where my environment to develop for IoT was, and I mean, it's just not really cool. I mean, you open a VM, you have your IDE inside a VM, so it's quite slow and so on. And now the Cube environment is fully working on any platform, so working well on Mac, on Windows, and I think in Linux also. So you can choose your environment. That's really cool. And they have the Eclipse version. It's still Eclipse, but Eclipse is quite cool for C. The Eclipse version they are providing is stable also. So with CubeMX, you can generate your project with, as you say, all the hardware configuration already set up, and then you can start developing. So basically, for example, for my SDK, I'm generating all the project with CubeMX, and then I have just 2 lines to modify inside the generated project to make the link with the SDK, and then I can develop on the SDK. So it's that way it's easy to when there is an upgrade of CubeMX, for example, we can regenerate the project with a new version of CubeMX and all the associated libraries, and just modifies 2 or 3 lines in that project, and all the rest of the code stay unchanged. And that's really important to think when you create a project. I mean, if you use your own code, your own SDK, or your own code base, it's really to think that you may have to update.
Yeah. Yeah.
And so,
I mean, and it may be 2 years down the road, and you haven't looked at this in a long time, and all of a sudden you're having to bring it a few versions up to date, and no, that can be a huge pain. Now, I've got a question on the CubeMX though. Can it go both? Can it generate from the graphics side and the code side? I know for a while it kind of, you could get it to work, but it wasn't as direct, I guess. But I mean, if you're going from SDK into the graphic, can you do that, or?
No, I mean, the CubeMX is using a configuration file, which basically define what is displayed on the UI, and from that configuration file, it's generating
skeleton
the source code. So I don't know a tool that can get from the source code the information to regenerate the configuration. So in my point of view, just go in one direction.
Yeah, I gotcha.
But maybe they will optimize or change that. But basically, I prefer it going in one direction, because I think it's really, in your code, like setting a GPIO as an input or analog or thing like this. Sometime in your code, you set it up as analog, but later you switch it as an input or an output. And so I don't know how the UI could manage such thing. And then when you regenerate the code, it could do a bad.
And it does a good job about the way it handles some of this now, is because it says, your code goes between these 2 comment lines.
Yeah,
and
cool.
so and so exactly where your modified code outside of the skeleton, I guess, is, and you can tell it not to touch that code, or you can say, you can. So it's gotten a lot better, but going both ways is kind of difficult. So your SDK, is available on the GitHub. Anyone can use this. Anyone can pull this
Sure.
down, and there's and you use this SDK to build, I guess, these other other projects out with. So you have, I guess, code that someone can take a look at, and you see how to implement this.
Yeah, sure, exactly. I can share that. If you go to my GitHub, the project is STM32IT SDK, which is I'm very bad in naming because I did that SDK to be not related to any hardware. So there is basically it's explained there. This is the SDK. So it's between hardware implementation and end user application. And so you can have many implementation. In fact, there is three separated. All the part you see on the top of the IT SDK has nothing specific to any STM32 or anything else. And you just an API basically, and the STM32 layer is implementing this API. So, for example, some student that has worked this year in implementing the ESP32 integration. So you can imagine an RF or any MCU at this layer. So it should not name the STM32. It should be any MCU IT SDK, but basically I did STM32 at first. And so after you have different components that as described, and some drivers also for sensor, GNSS, and so on. And every time you also have I mean, if I take a GNSS, for example, there is a GNSS abstraction. So you can have a end user application that work with any GNSS hardware because the abstraction, the driver of the GNSS will make it compatible.
Gotcha.
So encryption and so on. So there is a description of all what is supported in it with different. So for LoRaWAN, for example, the Murata, the ABZ Murata, it's the one I'm mostly use. So that's cool. And what is also interesting is I built this SDK for one reason. There was some Arduino environment or some also STM32 systems, operating system. But when you are targeting big chip, it's okay. But when you are targeting a really small chip, I mean, like your Hello World, which is just blinking a LED, that can be sometimes more than 8K or 16K with certain SDK. So everything is customized in the SDK, and so you can reduce the SDK footprint to something like 2 kilobytes or 1 kilobyte. And so that way you can target really little system like STM32L011, which is something like I think it's an 8 kilobyte MCU.
And so all of those are your low power families, right?
Yeah. I mean, I use I'm using to low power every time. It's really IoT oriented, so low power and in IoT is something really important. And so the SDK supports Sigfox and LoRaWAN with different chips. So you can do Sigfox with S61276 and LoRaWAN also with that chip. And so you can make a device supporting Sigfox and LoRaWAN. So you can have multi-system environment. And after, as you say, there is skeleton of project. So here is the explanation. But if you go to this example, basically you have link of different example. So if you want to do a Sigfox, or if you want to do LoRaWAN, or if you just want to have a LED blinking, there are some projects you can directly with including the CubeSDK, the CubeMX skeleton, and so on. So you can just develop that, and that's it. And what I like the way it works. I mean, in terms of configuration, it's config template. So you have template file, it's .h header file. And so you have template to instantiate. And I mean, all the feature of the SDK are switched on, off, or configured using, I'll take the driver, which is not the right one, with a header file. So you can activate all the feature or deactivate all the feature with that. Define when you are, if you want to have a deep sleep. So you decide what you want, what sub-module you want to enable or disable, the GPIO you want to switch off or you want to keep, and so on. The different GPIOs that will wake up your system, and so on. And so you do all this configuration, and that's it. So there's no code basically to configure or UI or complex XML file, it just gets defined. And so if you want to have something which is really small, you just switch off all the different modules and you can go back to 1 or 2 kilobytes for the SDK.
That's very cool. That's very cool. In the repo that you were just showing, I thought at the bottom, it explained how to set this up, set the SDK up with CubeMX.
Yeah. There is some settings to do, but basically, you start CubeMX. There is some configuration you need to do to manage the watchdogs, the deep sleep mode, and so on. So there is some configuration that are explained to go low power if you want to wake up on your hour to have some specific settings. So everything is defined there. After you just generate your code, so you get all your project somewhere. And once you have generated your code, what you do is you just import the SDK. So for that, you just have to add the SDK source and include a directory and insert that in your project. So basically, it's through the UI. You have to click to make some of the click. And when you've done that, you need to do that. I mean, you just need, in fact, you open the code was generated by the CubeMX. You add 2 includes. In the main, you add ETSDK setup, and in the while, you add ETSDK loop. And as you explained, in the CubeMX skeleton, you have some place where you can put end user code. And so if you modify CubeMX and regenerate the project, this will stay there. So you can modify CubeMX 100 times if you want. This will not impact your development.
This next part, I've got a section like this in my notes as well that says, okay, every time you just do these 4 things whenever you're regenerating a project.
Yeah, that's really important.
Yeah.
Because you always, I mean, when you do a development, you will say, oh, that's GPIO, it should be an input, I made a mistake, or oh, I will add a LED there, so I need to add one more. And so you have lots of modification of this. Yeah. And there is only one tricky thing to you need is, I mean, all the GPIO are set up by CubeMX. But when you go deep sleep, you want to reset to redo this setup. But I mean, the CubeMX, for example, set a default value to 0. And when you wake up, you don't want it to set up to 0. You want to set it with the last value it has, for example. And so you have to rewrite a GPIO config. So usually you copy and paste the GPIO setup function generated by CubeMX, and you just remove unneeded things. And after that, I mean, if you just modify this, you have something working deep sleep with a regular wake up with a setup and loop like an Arduino. So you have quite like an Arduino environment with deep sleep operating. And after you do what you want to do.
Yeah. Well, very cool, man.
Yeah.
I like it. Thank you for sharing that with us today. And I guess we will have all of these links down at the bottom here, so everyone can check these out on their own time. And very cool.
I can share that also if you want, which is my, I mean, what I'm doing. You ask me what I'm doing currently, and most of my time currently is installing hotspot on rooftop. I spend all my weekend to do that.
Excellent.
And I'm quite proud of what we have done so my that's my city. It's Clermont-Ferrand, so it's I mean just yeah, for people. I'm happy because we see Clermont-Ferrand from I mean from really far now.
Okay.
So here's the France. We have Paris, which is there. There's the Mediterranean Sea here, and in the middle here we have Clermont-Ferrand. So we are in the middle of mountains. Here you have a big volcano there, and so here is our helium deployment. So you see that, I mean, we start having many hotspots, but I mean, the density is good. But what is really cool in my point of view is, I mean, we are well organized, and we are really good people in Clermont for deploying the network. So we have found some really strategic places. For example, this one is going to deploy next week. It's a radio tower. We also have some radio tower here and here.
Nice.
We have some here. It's not a radio tower, but it's I mean, a radio amateur installation, so it's also quite good. Here we are on top
You
of
take advantage of
mountain.
the elevation.
Yeah, we have a
yeah.
we are on mountain. Here there are also on mountain with all of them are installed with rooftop antenna, so it's quite good. And so we are doing the coverage currently with different devices. So I'm using that one, but I also have my Fox tracker, which is a tracker I'm developing. It's a tracker like this, running Helium and Sigfox and TTN and so on. And
Very cool.
so it's also doing mapping with a really long autonomy. And so you see that, I mean, we did not map all because I mean we should cover all this area. But I mean, at least here is all the city center, or what you see, which is white, clearly mapped, is the city center. So
it's fully validated. I mean, that's boots on the ground, validated coverage. Yeah.
We still have some places there, but I mean, here is a mountain, so we need to walk about half an hour to reach this point. So we will get them.
Yeah.
There is also this point. It's I mean, it's a famous volcano we have. It's the Puy de Dôme, which is also the name of the region. It's a Puy de Dôme, and so we also covering the Puy de Dôme. And so I mean, all the city is covered. The city around, you see, it's the north of the city. Here it's covered also here. Here there's some other cities there. The second big city in the area is this one. It's covered also. There is a new hotspot here. We are going to the south now, and all of this, there are big area where there is farming, and everything there. We did not make the coverage yet, but we know that everything is there, is covered. Thanks to the spot we have here. And so we can start really imagine real application. For
Yes.
smart city, we can do smart city here. For smart farming, we can do smart farming in all this area. People who want to do smart building application, smart home application, yeah, it's ready to use now.
And so you could just have a WISblock, a little board like this, and anywhere in the city center, or in this area, whatever application I write on this is just going to work.
Yeah.
And I don't have to do deployments of antennas, of gateways, of any of this. I can just develop something on this little thing, program it, and just spray it with sealant or throw it in a box and throw it in the field, and it should just work. So
yeah, and you can imagine really cool thing. I mean, I had ideas like doing a kind of geocaching in the city. So you can have some little box with a system on it and with like a NFC card. And so when someone puts an NFC card on the device, you get a message. You can get a score, and you can create a game, for example, with thing like this on this. I mean, there is no limit. In fact, you just have to.
Oh no, absolutely. Be careful when you're hiding, electronic devices and flower pots downtown. But but yeah, there are a lot of fun use cases.
And we have a project also where we start talking about this with the community. We had a first community beer event yesterday with some of the members of the community, and we had we started the idea of a project about sending a balloon with a tracker to follow it at first to see the coverage of our antennas, what distance can we reach, and what is the antenna that gets the longest distance in the area. And after, maybe if there is some hotspot all over to track this balloon on higher direction. So it's something we're gonna put in place. I don't know, in the next 4 months time.
Very cool.
We got some hardware and
yeah, check out the high altitude ballooning project that was on Helium Hacks a while back. I think it's up on YouTube.
Oh yeah,
man, that was a great video. And he will on occasion, Star Watcher on Discord will launch a balloon and throw a link to the dashboard up into Discord if you want to kind of follow the metrics. Yeah. Live, which is very neat.
Yeah, it would be really cool. Yeah, it's something we need to we will have to do live. Yeah, it's gonna be something.
Oh yeah. No, cool stuff, man. I got a little carried away talking with you, man. But we have to do this again. I sincerely appreciated you coming on the show and enjoyed this. Thank you very much, Paul.
Hey, thank you, Joyce. Really happy to discuss with you all this project. That's pretty cool.
But no. I'll like I say, we'll put all the links down below so folks can reach out to you over at disc91.com. And if there are any questions, please leave them in the comments below. And for Paul or myself, we'll try to address those and get back to you on that.
You can find me on Discord on disc91.com. So yeah, don't hesitate if you have any topics that are interesting you and you want to discuss a bit about. Just let me know. It's a pleasure. Yeah.
Paul, thanks, man.
Thank you, Trace. Talk to you soon.
See you next time. Adios, man.